Thank you. Hello everyone, this is Can from Istanbul, Turkey, and I am with Serkan today. And we will be talking about the playing with electricity and red teaming in power distribution companies or hacking in the power distribution companies. Before getting started, I would like to thank the ICS Village team having us. It's really great opportunity to meet you all. We really like to be part of the community activities all over the world. We also some community activities in Turkey as well. So it's really great to be meeting you all over here. Basically, we have 1 hour with you, and basically we have 3 parts of presentation. The first part is overview. We will make a brief information, give a brief information about the electricity architecture and power distribution company architecture, and give you some SCADA application architecture upon it. And then we will discuss red teaming scenarios, and then we will perform some attacks on our simulation lab. Actually, thanks to Serkan, our simulation lab had some Murphy issues. We changed our hardwares like 4 times last 3 days. But it worked at the end of the day, and we did videos for this presentation to avoid any problems. So we will have some videos and we will talk upon it. All right, so let's do it. So Serkan, please go ahead and introduce yourself, please.
Thank you, Can. First of all, good afternoon for the American side spectator, and maybe good night or good evening for the European and Asian side spectator. First of all, I'd like to thank you for giving us for opportunity in this beautiful organization, and I'd like to express my pleasure being there. Now I will give information about myself. I am Serkan Temel. I am electric and electronic engineer. I have 7 years experience about industrial control systems, SCADA systems, based on electric distribution, transmission, and power generation. For last 1 year of my career, I'm focused on the cybersecurity in SCADA systems and also focused on the industrial control system cybersecurity topics. Thank you, Can. We can go on now. Presentation.
I am also an electronic engineer, and I have more than 8 years cybersecurity background. And last 5 years, I mostly concentrated on critical infrastructure and ICS SCADA cybersecurity. At the moment, we both working for CyberWise for critical infrastructure cybersecurity at the moment. And today, as you mentioned, we will discuss electricity subsector and power distribution, red teaming, and cybersecurity. All right, we want to start with why electricity matters, actually. It's not just for us, but for all rest of the world. It's the backbone of all critical infrastructure. When it fails, it directly affects the daily life or the modern life fundamentals. And for example, it affects health sector, transport sector, transportation, and finance sector, and so on. So once it fails, it directly affects people and public safety, and it's a really backbone of the critical infrastructure. So we want to take that part, and we wanted to build a presentation upon it. So we will be discussing about the red teaming in power distribution companies. But before it, we need to understand the electricity architecture in a process-wise. Basically, it has 3 parts. We have power generation, we have transmission lines, and then we have power distribution part. Most of the time, power plants and power generation located in the out of the city centers. That means we need to carry electricity long way of kilometers. It means we require the transmission lines. And finally, that means we need power up-down operations. Once we are over from the transmission lines, we came up to the power distribution. Actually, it is the last line of the customer touch. I mean, if something fails in power distribution part, it directly affects customer and our business. To be honest, the distribution companies and electricity distribution process is not too much complicated when we compare it to power plants or petrochemical industry. So it is easy to attack and also it is easy to defend. Serkan, would you like to add
Yes, I
something?
would like to at some point in that presentation, we today we tell you distribution, electric distribution, but I would like to be aware of this point. Transmission layer is the critical part of the electricity architecture because it's the bridge between power generation and power distribution, and it's the backbone of the electricity architecture.
Mhm.
Today topics are distribution, electricity, but transmission is the very, very critical in the cybersecurity perspective.
And actually, it depends over the countries or over the regions. Sometimes it's operated by the government, sometimes it's operated by the private companies. It really depends on the region and country's perspective. But I really agree with you that it's transmission lines also the core of the electricity architecture. Thank you. So let's deep dive into the power or electricity distribution infrastructure. First of all, it's a really great example of the SCADA because you have people, which means the supervisory element of the SCADA, and you have remote locations. As you can see on the screen, there are lots of different substation connected via different type of communication medias to your control center or emergency control center. So what we said, it's a great example of the SCADA application because you get data from all over the different remotely located substation, and sometimes you control over the remote substations. So on the other hand, you have remote offices like payment offices, headquarters, government agencies to report for, or you have direct integration. For example, in Turkey, renewable power plants has to report the nearest power distribution company for the regulation. Basically, what we can say, there are lots of remote locations we have that we need to control, and that means we need different types of communication media. In distribution companies, we really need to take care of the communication media security as a part of the defense mechanism. On the other hand, sometimes some companies or some governments or some countries has smart meter application, which means smart meters has direct affected electricity. They open and close the electricity via metering control center through the smart meters. Uh, why I'm telling you this? Because it will affect our red teaming scenarios and understanding the infrastructure. What we need to understand from this slide, we need the loss of high level of connectivity. There are different types of communication media, and we have lots of different type of substation and equipments. And the rest of it, we have lots of different type of integration. All right, I gone. All right, I will give a brief information and pass to Serkan stage. We discuss about the electricity architecture, and then we discuss about the power distribution architecture. Now we will discuss about the SCADA architecture. It's also distributed in the server side, but before jumping into it, we need to understand there is a need of high level of connectivity in such a power distribution company. Sometimes you need to connect the outage management system, ERP application, call center, and so on. Maybe Serkan give some example about that.
Yes, we mentioned about the previous presentation. We said that distribution, electric distribution, touch the customers. So this means that in the distribution company, so many customers works into the like customers management, outage management, VFMs, other stuff, so many stuff for the customers. Reason of that, the distribution SCADA systems must be and have to be integrated IT software applications, like John mentioned, that's OMS, like VFM, like the other companies, third-party softwares. Because of that, distribution SCADA systems a little bit different from the transmission and power generation SCADA systems. And also, And also in the distribution network, so many substations. This means that so many data, so many connection station. So it's we need the powerful SCADA systems. We have to separate this load to the separate server, like application server, like communication server, like data server, like backup server, and so on, like HMI server. So distribution SCADA systems a little bit distributed and separated structure.
Mhm. It's very similar to IT environment actually. You have some type of application servers, communication servers. It do some kind of load balancing, and it requires really great integration of IT application or business application. Sometimes it's part of the SCADA applications, like we called outage management system or call center. They are directly talking or integrating with the our SCADA application, because once you have a blackout or a kind of the blackout or shut down the electricity, you will get some calls, you need to reach out your customers, you need to get some data from SCADA. So it's really integrated with IT applications, sometimes cloud applications. And on the other hand, you have untrusted parties like vendors, remote offices, other type of control centers or government agencies. So sometimes it's done via the firewall, sometimes directly connected to your industrial equipments. It really depends on the customer strategy, or sometimes they are not really aware of what kind of communication channels they have. But what we need to remember through here, this our SCADA architecture is distributed as a server roles, and it's like a IT application, and integrate it has integration with the business side, and also it talks to the substation through the our communication media. So I will leave the comments to Serkan about substation, because it's his expertise, lots of years
Now
there.
we have talked about the substation architecture. In the substation architecture and distribution substation process, we have some main devices for the process we use. The first one is RTU. RTU is a telecontroller which connects field devices to the SCADA systems. We think as a data concentrator or data transfer devices RTU. Energy analyzer is a energy meter which get information from the CT and VT transformer from electric sites information and translate in the digital sites and give and directly send this information to the SCADA systems. Protection relay is a critical equipment in the distribution and also transmission and also generation, as you know that. Protection relay is the first IAD device, first electronic device connected to physical electric system. It is a bridge, cyber and physical world.
Mhm.
Reason of that, protection relay is the most critical part and most critical device in the distribution systems. As mentioned in cybersecurity perspective, if you want to shut down the electricity, you have to control the protection relay. But maybe you can attack the way maybe attack the SCADA systems. It's just blocked our monitoring from the field side. But if we want to control electricity, shut down the electricity, or re-energize the electricity, you have to control protection relay. The fourth device is the smart meter. Smart meter, as you know, that's for billing purposes and maybe low voltage side for customer side, shut down electricity or re-energize electricity. This last two devices is physical device, which means the first one is low voltage circuit breaker. It is control the electricity line, and the last one is the medium voltage cubicles, means circuit breaker also inside these cubicles. It controls the electricity line networks.
Mhm.
Next slide, please.
I think, yeah.
Yes. Yes, we headline IAD device, protection line device. This is I would like to say it again because it is very critical. I, protection device has two parts. One of the hardware, the other is the software. The hardware side, they have analog inputs, analog output, digital input, digital outputs, and the other serial or Ethernet interface. Voltage and current information takes with analog inputs modules, and also control analog system like set points, power, like set about the frequency, let's set about the voltage. You have to send analog outputs, and digital inputs and digital outputs mostly critical because digital inputs comes from basically circuit breaker position, isolator position, the other information about the physical systems. And digital outputs is control the circuit breakers, means that you control the electricity. Because of that, in the SCADA systems and most of the communication protocols or anomaly detection or the cybersecurity perspective, we focus on the digital output signal.
Mhm.
In the beginning of this device, they have serial interface because in that time no Ethernet IP world. And today's most of device has Ethernet interface and it gains advantage of the Ethernet IP world. But it is some cause of the side effect from cybersecurity. This gains of advantages. I will tell about later. In the software side, communication protocol. Communication protocols means that industry communication protocol like Modbus, like Profibus, like IC 104, DMP3, the other. Uh, this helps communicate with RTU or communicate with the SCADA systems to send information to the upper level.
Mhm.
Logic functions control like circuit breaker or other blocking materials functions, logic functions, and configuration interface. This is the critical part of the IAD device. As I mentioned, that they have Ethernet interface, and most of IAD device nowadays use web service interface for configuration software or configuration interface. So this is the some vulnerability about systems as the weak point of the this IAD device nowadays.
Thank you, Serkan. Actually, we always get afraid or get freaked about to touch such intelligent electronic devices because, as you mentioned, one part is physical that controls electricity, and one part is cyber. It's RTU or SCADA applications, and it's like a last line of the physical and cyber breach. Once you control it, you control the electricity. You can control it through the RTU, or you can directly send commands to IAD, or you can trigger some SCADA application set points, and it will directly affect the intelligent electronic devices. But once you're planning a red teaming or pen testing activity, you need to be aware of such a devices can affect the electricity, and you need to be really careful what you are playing with. All right, so now we can discuss about red teaming approach and red teaming scenarios. Before jumping into the details, I wanted to discuss how much red is that, because since it's a critical infrastructure, since it's a last line of the customer touch, can we be really free to be really red teaming? In that case, most of the asset owners and most of the cybersecurity companies get afraid to or avoid the consequences of bad thing happens. So I may say that nobody does directly red teaming. Maybe it's like light pink teaming, let's say, because we really need to be aware of that. The public safety and process safety is much more important than your color activity. So you really need to take care of the process. You really need to take care of the public safety, because we always think in a that way. If we shut down electricity for the hospital, and if we kill someone in that hospital because of no electricity, so it really has a great boundary for us to do our test or pen testing activities or red teaming activities in a controlled way. So it's not really red, light pink maybe, but to understand each other in a better way, I want to express that part as well. So I would like to mention about the core steps. We divide into 5 main steps. Actually, we discussed about the first two of them to understand the process, understand the architecture. Once you do any red teaming activity in any kind of ICS infrastructure, in that case, we are talking about the power distribution. We gave brief information about the electricity architecture, distribution architecture, SCADA architecture, and substation architecture. And we told that power distribution companies process is not too much complicated. We have very limited type of signals compared to power plants and petrochemicals. So it's a really easy process, to easy to attack and easy to defend. Now we need to define our landscape, and then we will try to create some kind of scenarios to directly develop for the red teaming activity usage. And then finally, we will perform some kind of attacks in our simulation lab. I really don't want to talk about the IT based or getting into the IT and then jumping into OT kind of red teaming activities or landscape. But once you are talking about the power distribution red teaming, we wanted to give you brief landscape information that what you need to know, what you are going to face, and how it will affect your planning. So basically, we have 8 categories that we will discuss today. The first one is protocols. There are different types of protocols you will see in the field, in the distribution companies. Basically, in SCADA part, I mean the wide area network, you will see ISC 104 and the MP3. And substation level, you will see different types of protocols, sometimes GUS, MMS, and so on. And upper level, in supervisory level, you will see soft bus, and the control level, you will see Modbus, TCP, RTU, even sometimes serial protocols. And then if you have smart meters, and even in SCADA application, you may have the power line communication. It's still PLC, but it's different term. We will discuss it today as well. And then we said that communication media is very important. If you get into the communication media somehow, let's say you get into the APN network based on GSM, or you get into the RF signals, you then directly interact with substations, interact with RTUs, and interact with control center equipments and emergency control center equipment. So communication media is also too much important for us to red teaming planning. On the other hand, you need to be aware of the third-party integration. There are different types of integration. It depends on the country and region and the regulation. You see some of them in our list. And also, as an asset owner, you have some kind of remote locations or local locations like control center, emergency control center, metering control center, headquarters, payment offices, or communication center for like RF towers. So asset owner locations also matters to us. On the other hand, substation is very important for us because it is remote located and physical and cyber control is very limited compared to control center or emergency control center or headquarters. In that case, you will be facing with industrial protocols on industrial devices, and you may apply some kind of hopping attacks. What I mean by that, once you get into the specific remote substation, you can jump over the other substation, you can jump over the control center or emergency control center. You may create some fake signals. It's like coming from the old remote substation and so on. So it's very great entry point and great defense point for us. But I should stress out that in substation, we have some physical controls. For example, if someone opens the door, or if someone opens the cabinet, if someone moving in the substation, it creates some alerts and sends signals over the 104 to the control center. So we still have some type of controls that we need to be aware of when we plan SOC activities or when we plan red teaming activities. On the other hand, technology, I'm sure that all the villagers have proper knowledge of them. I don't want to express each of them because it's like the IT wise pen testing or red teaming, because it's server, network devices, and some kind of field devices. So I don't want to go each of them. And on the other hand, we have people, for example, in Turkey, we have a specific regulation for assessment in the power generation and distribution companies, and it requires social engineering activities for the energy people, let's say the asset owner people. Sometimes we see that some red teaming activities hit the vendor engineers or OT partner or engineering company engineers. So the people's segment is also really very and different types of mechanisms they have. For example, in Turkey, we need to do physical pen testing, we need to do phone calling, we need to do email-based social engineering. It's all written down by the regulation. And also yet another landscape for us, the industrial process. We will discuss it yet in another conference, because since it is the less signals and it's less complicated in the power distribution and power industry, the industrial process vulnerabilities may affect public safety directly. So we avoid to mention the entry points of um, process vulnerabilities, but we can discuss it later in for another industries on the following days. All right. So I hope we understood the process, we understood the architecture, and define some kind of landscape. Again, it may change the region, country, and the regulation, but we need to understand the basics of a distribution. So we need to create some kind of scenarios. In this presentation, we created three types of scenario. We have created a specific table for that. I will discuss it through them. And it's, again, not IT-based red teaming or pen testing. We try to create some kind of directly effect on electricity-based scenarios. So in this scenario, we had a chance to work with our IoT team leader and hardware security team leader with Fatih Kayran. Actually, he developed this scenario and applied in the field. Once upon a time, we were in the distribution company and came up the idea that we figured out somehow the smart meters were controlling the city's electricity, which means if we could find a way to send a proper command to smart meters, it will directly shut down the electricity. In that case, that smart meters were talking through the power line communication. So we created our scenario based on this. So to understand the teammates to each other in a better way, we create such a table to define our success criteria, difficulty factors, and decide if kill chain is required or not. I will walk through the one table, and I will pass through the rest of it, because we will perform real-time simulation for the rest of it. In this scenario, we targeted the shutdown electricity, but before jumping into that, we classified our tactic and techniques based on MITRE, manipulation of control and manipulation of weave. And our entry points was smart meter power line communication. Complexity in this scenario was high, difficulty was high, because unknown protocols were there, specific hardware design is required, and high voltage work environment can be dangerous because we lost one of our laptop, and one of our team member got injured during this test, because you work with the high voltage directly with the plugs. To better understanding, you plug the smart meter into the city network. So you turn into that specific smart meter into weapon to target to the electricity for a better understanding. I will discuss it through this presentation. So dependency was the communication interface reverse engineering or protocol reverse engineering. Required time was high for us. And also, what was our success criteria? Understand the protocol, send and receive packets on the power line, send command to cut off the electricity for a defined area. Sometimes we create some SOC success criteria for our customers to detect better the next attacks. In that case, it could be hardware or smart meter log management, OMS log management, call center log management, or smart meter application log management could be a success criteria. In that case, we define log sources for red teaming activities, and then we define a purpose, method, and kill chain activity. In that case, our purpose was shut down the electricity via unexpected point of entry through unexpected communication media, turn plug and meters into industrial attack equipment. So our idea was simple. So power line communication works through the power signals. You modulate it and put your data into the electricity signals. So it directly talks through the electricity. I think yesterday there was a specific session about that. In that case, we will look into the how it's used in distribution companies. In that case, we have a data concentrator, which is directly connected to different types of customers, home or street lighting, and there are smart meters, and there are some power line communication interfaces, and it connects to the backend system through the API, and in that case, over the internet. So guess what? It was the broadcast messages going through the specific power line. If you have specific hardware, you can develop it, or you can turn smart meter into your tool. In that case, we made it, and we were able to understand the reading data and the shut down the electricity commands. So since it's broadcast, each of smart meters get the data, and once you gave order, everyone gets the order, but one of them apply it and report back to center. So once you sniff the data, you see the smart meter ID, and in that case, the power line communication, we're using the DLSM QSM protocol. In that case, that specific number defines the shutdown the electricity command, like the double command in one of our very similar. And also in that case, we were able to get readout data. In this case, this is the readout code for DLSM QSM protocol. What we are trying to say that you don't directly attack the SCADA application, RTUs or IADs. The best way and easy way, find yet another proper line to end of your goal. So in that case, the power line communication and smart meters gave us a chance to shut down the electricity, but you need to deal with high voltage electricity, you need to deal with power line communication, new type of protocols, modulation, demodulation, and encryption type of things require much more time. But most of the time, the asset owners and the pen testers doesn't pay attention on that channel. So you really create a value for your customer and the people safety in that case. So as I know, the European countries also have great implementation of smart meters. We need to take care of these standards as well. Okay. So our last two scenarios based on the RTUs and industrial protocols, we will show how to do it industrial red teaming in a real lab environment, which took days for Serkan and got old during these sessions. Basically, we have two different scenarios for this presentation. One of them, extracting data from config files without further reverse engineering or further implementation of anything. Think about that, you have some type of configuration files, you don't have any access to OT environment or substation yet, but you will figure it out some type of data to plan your next session of red teaming activities. We have a specific example of that. Since I discussed deeply and very detailed the last table, I don't want to discuss it losing any time on that. So I will jump into the next one because we will discuss it real scenario. The yet another scenario for this session is the remote substation protocol attack. In that case, the attacker needs to interact with the substation equipments. It can be done via Raspberry Pi implementation and connect through the Wi-Fi and so on, like we did in our lab environment. And we will shut down the electricity using the protocol commands. Once we understand what kind of protocols used and how, once we understand the protocols, we will figure it out to where to send the data and finally send the data to shut down the electricity. To have better understanding each other, what we are trying to say, if you are planning to red teaming activity in a power distribution company or assessment, you need to understand the process, you need to understand the architecture, you need to understand the landscape. Once you have a three element, then you can create your scenarios. You need to think out of the box, but that box doesn't mean you can go out to public safety rules or process safety rules. So it's really hard to balance. And we want to give you some simple ideas to reach out your end goal. Rather than implementing some IT-based or IT-related red teaming activities. I think I can be free from now and put Serkan into fire. So,
Thank you, Can. Thank you, Can. As a traditional, we have face to face with the Murphy's rule, as Can. But finally, we succeed on the setup a lab. Now I have give information about lab setup. It's a very simple part of substation process. We have one RTUs, ABB 140, and one IAD device, one SCADA server, SCADA PCs, and also one switch. We use Capware software as a SCADA master, and also we use Modbus TCP protocol and also ISC 1/4 protocol. Modbus TCP use in IAD device between R2 and ISC 1/4. We use it R2 between SCADA, yes, and Capware device. The tricky part is the implemented hardware substation as an attacker. We think that we have some Raspberry Pi device or the other device as attacker machine.
Before jumping into details, I would like to mention that this setup doesn't indicate any vulnerabilities on ABB RTUs. It's just a simple RTU that we could use on the market, and we know how to configure it. So we will do some protocol-based simulation, but it doesn't just affect the ABB. It's based on we leverage of the protocol usage actually to avoid any misunderstanding.
And also, it is very common RTU used in Europe and Asian sites. This, and also, this is the second reason we choose this RTU. Now we can jump into the labs videos.
All right. So we will start with interfaces and signals.
The first video is about configuration RTU.
I jump into that. Just a second.
Yes, we use RTU Util 500 software for programming RTU, configuration RTU. We created it before and open existing project. This part a little bit takes time. It may be boring. They hide the project file deep inside my file system. Yes, and Turkish character error. Now, this is the R2 Util 500 software interface. This is the network tree. We have three communication line. One is ISC104 for SCADA communication. The other one is Modbus TCP for ID device, Modbus communication line. You can easily see that some parameter of the communication protocol. Yes, it is the 104 communication protocol setup. As you see that ASTO address structure, information structure, maximum length of idle, and then this is the Modbus TCP site configuration. This is network tree. Now we in hardware tree. In the hardware site, we choose our R2 main CPU model, and also we add the field level signal information in that site, hardware site, and also as you see that the Modbus TCP communication configuration zone. This is the IP address of the ID device, and also the again 104 configuration section. Now this is the RE2 interfaces. This is it has two Ethernet interfaces. As you see that IP address of the interfaces. And this site we configured our field level signal like active power. It is the Modbus site read holding register index number 13, and this is the SCADA IS 104 site ASTRO address 1 information object address 103, and the other signal like phase A current, phase B current. We record all and show the all parameters of the signal because
You may want to create your own lab, and maybe you want to replay in your own lab. So we wanted to give you brief info in this section. The other sections will be much more faster, let's say. But once you understand that part, the configuration, it's much more easier to understand the rest of the simulation.
This is a type of the Modbus signal, as you see that force commands, signal commands, and register read call status. Read call status used for the information, single point information, digital input like position of circuit breaker. And switch control means that sends control command to the circuit breaker, power limit set point, and the other metering information, phase A current, phase B current, phase C current. It's a very simple model of the substation.
So we can jump into the second one.
Second record. In this record, we directly connect the RE2 web interfaces. As you see that this is the IP address of the first Ethernet interface. Use username and password. In that site, you can easily see that configuration management site. You see that the configuration file, which configuration is now active. When you update this configuration file, and also get configuration file from the device, and also delete this configuration, etc. And also direct on site, you can easily monitor system log, system event status, and client session log, and also hardware tree. Hardware tree is the live monitoring about R2, especially in that site. You see that R2 is active. R2 is operable means that it's connected to ID device. As you see that CPI switch position is on, and also metering information about systems. It is live data, real-time data.
Now I can talk about a little bit configuration file if you wish. Our third video related to configuration file and extracting some data. Again, it doesn't integrate any vulnerabilities on the R2, but somehow if we reach out to backup systems or if we reach out to file server in the IT system, once we have a configuration file, now we will download it and extract some data from it. It's really easy actually before furthering reverse engineering implementation. In that case, we are not into the remote substation. We are not in the control room. Somehow we get data about the configuration file. It can be engineering workstation, file server again, or backup system, maybe engineering partner workstation. Once I get the configuration file, I am directly able to see what kind of R2 is used, what version, what purpose they are using, what kind of interfaces and what kind of IP addresses they have, and sorry, and also what kind of protocols they have. It will affect my further planning actually in the red teaming activity. What kind of devices connected to that RTU in substation, and what kind of signal parameters they are looking for it. So once I have that information without any probing, any scanning activity, or any physical attachment, it's really leverage of your efforts once you have that kind of specific knowledge. We have also some specific projects, the reverse engineering to read other data, not people readable format at the moment. You have much more better information and knowledge about the targeted system. So in that case, we want to show you, you don't need to go to the control center or remote substation. Somehow, if you are able to get config files, you may read directly with the Notepad++ and read some data, understand the process, understand the protocols, interfaces, and plan a better red teaming activity or targeted attack into the targeted system. So I will jump into your part, Serkan.
Yes. The fourth video is about the normal traditional application and communication with SCADA systems and RTU. First of all, I would like to show to my IP address and same subnet with the R2 interface one. And then we use, said before, CAP server as a SCADA software, SCADA master program. This is the configuration of the master sites, CAPware sites, CAP server site configuration file. As you see that communication address, common address, advanced settings, network interface, as we have same subnet, same address, more advanced parameter for IC104, originator address, like, and also network interface. Network interface means that it is the IP of the radio and the port of the IC104. And this site, we also configure our signal. This means that it is analog short float volume. Astro address 1/3, and so it is the breaker control command single command means CJ.
Actually, it will directly affect the open and close breakers. Later, then we will apply some scenarios. It's really important to understand what type of parameter and what type of commands they take.
Now we connected to R2. As you see that this is the real-time data. As you see, active power 2400. And also breaker control is 0, breaker position is 1, means that the closed. Now we send the breaker control command is 1. Yes, it takes the command. In the real time and real time operation, when we send this command, we re-energize circuit breaker or shut down the circuit breaker with this command.
All right.
Now, and also I would like to show some Wireshark traffics between Kepware and Retu. This is the Ethernet. We apply our display filter for IS104. Yes, as you see that it is the test frame in the protocol. Now we resend the command again and show the traffic. Yes, this is command, single command. Astro address 107. As you see that, this is the Wireshark single command. Address is 1, IO address is 107, and also set command value is 0. As you see, you can easily get this information from the Wireshark because the IC104 is a open text protocol, not encrypted or hash protocol. You can easily get information from the traffic.
In that case, you see that the single or double commands take place in ISC 104. In that case, we send the specific shutdown or open command in a targeted area. In case it was 0, it means we shut down the electricity through a legitimate traffic. I mean, it was a traffic generated by the control center. Now we will try to apply as a attacker point of view who is in the remote substation via implemented hardware.
This is the 5 video of us. Yes, we have information about the second interface about R2. Now in the attacker machine, I configure my IP address for the second interface of the R2, as you see. Now I use mmap for some research and some search vulnerability or open ports.
In that case, we are looking for who has the IOC 104. In that case, in that protocol, use specific ports if nobody change it. So we are looking for in same subnet if someone has that specific protocol. Please be aware, it's an attacker point of view and got into the substation looking for some IOC 104 endpoints and
two device. We found it. This is the Retu device, as you see from the IP address, and also IOC 104 is open port, and also service is up. But now we have only information about R2's protocols and R2's IP address, but we don't any information about the signal and signal address. Now we use Kepware again. We configure Kepware again, as you see. We tried it one. Now it's connected to Retu. Now in the protocol structure, we have general integration commands. When we send this command, R2 get response and sends all information about in this R2 insight. We send GI command to the Retu, I don't know any information about the object address, but when we send this command, R2 responds to this command, and now we can easily observe which address and which type of information inside of it. As you see that
So
address is 1, IO address is 100, and value is also, as you see, 332, etc., etc.
So basically, protocol gives an opportunity to us to pull all kind of signals and data from the RTU for a specific protocol line. As an attacker, we use exact same tool, but it's simulation environment. Again, you can use your lab environment, that specific tool. Yet another tool we have, it's developed by, I think, the master degree student in Germany, called ICS test. And to be make sure all of you, we will send the latest command through the, that specific tool.
Connect again, reto. Now we send command again. Get information from traffic, and also we send command to 107. As you see from the Wireshark traffic, we send command and also on command. And also as you, from traffic, it is action confirmation from the reto in number of line 18 and 37. CSC NA act confirmation. As you see, this means that R2 accept this comment.
So basically,
Process this comment.
once you get into the substation, you pull data through the protocol, and you send the command through the protocol again. In that case, single command or double command supported by the 104, and then you are able to shut down the electricity. In that case, if it's your end goal, you may apply very different type of scenarios and red teaming activities, but we want to show you that it can be done. There are some safety mechanisms or configuration mechanisms to avoid it. Sometimes you implement the IP-based solution or anomaly detection solution to count that kind of activities. So in this session, we are end of our presentation with takeaways. We would like to stress out, during red teaming activity, we need to think out of the box, but we still need to take care of public and process safety. It's really a rule of thumb for us. Power distribution environment is not complicated as process-wise when compared to power plants or petrochemical, but it has direct affected the other critical infrastructures and customers directly. Power distribution companies have lots of different interdependencies. Therefore, information gatherers crucial role for red teaming activities. And power distribution companies easy to target and easy to defend compared to other ICS infrastructure. So we have 2 minutes left. If you have any questions, please feel free to ask. We will be on Discord as well. As well as we can. So Serkan, if you have any comment, please do it, or we can get to questions.
If you have any questions, we will be in Discord. We will be happy for your answer for your questions.
John and Serkan, thank you for your talk. I noted in the Discord speaker Q&A that I consider this a mandatory talk to watch for both learning about 101 and assessments. So really appreciate y'all dialing in and supporting us.
Thank you very much for having us. I hope you enjoy.